Okay, so we're going to get away from triangles a little bit, and we're going to talk about polygons today. So let's get to it. In geometry, a figure that lies in a plane is called a plane figure. A polygon now is a closed plane figure, and it has the following properties. So again, a polygon, poly just meaning many, so it is a many-sided figure. So this is, like a triangle is a polygon because it has 3 sides, and again, it has to be closed. So here are the properties. It is formed by 3 or more line segments, and what we do is we call those line segments sides. So we say a triangle has 3 sides, a square has 4 sides, so forth and so on. Also, again, it is closed, meaning all of the sides touch, right? They all meet up at a vertex. And the other one is that there are no curved edges. So a polygon has to be closed, 3 or more sides, and it can't have any parts of it that are round or curved. All right, each end point of a side is called a vertex of a polygon. The plural of vertex is vertices. And these vertices are important because this is how we name a polygon. So a polygon can be named by listing the vertices in consecutive order. For example, like if we wanted to name this polygon over here on the right, we could say this is A, B, C, D, E. So basically it doesn't matter what vertex you're starting at. It just really matters that you got to keep going around. You can't go like A, D, B, E. It can't be random. It has to be consecutive. Like go ahead and make a circle. It doesn't matter which way you make a circle. Just follow the letters around. Like we could also start at vertex C and say, all right, this is C, D, E, A, B. All right, good. So if you're listening, I would like you to try to find another way to name that polygon besides the 2 that we found and write it there on your paper. Next, a polygon is considered convex if no line that contains a side of the polygon contains a point in the interior of the polygon. So let's think about that, and let me break it down for you. So we are going to consider that this is convex, so that, you see these lines here? So none of these lines are containing a point on the interior of the polygon. So that's basically what all that means. In essence, again, if I were to break that down for you, it's that the way it helps me is that all of these vertices are pointing out. So this is going to be convex. All the vertices are pointing out. Now, a polygon is considered concave if a line containing a side of the polygon cuts through the interior, therefore containing a point on the interior. So you can see here how if you were to take a line and draw it through a couple of these vertices, it cuts through the interior of that polygon. So this one's considered concave. And again, all it takes is one of these vertices to be facing inward for it to be a concave vertice. So think of the word cave, right? You go inside the cave. So one vertex, only one vertex pointing in, and it becomes a concave polygon. A really popular example of a concave polygon is a star. All right, so stars, again, that's a really bad star, but stars are concave polygons. So next, we're going to classify polygons. And classify, again, when we think about classifying triangles, it's when we gave them one of those special names like equilateral, isosceles, so forth and so on. So again, classifying, you got to think of classy, fancy. So you're going to give something a fancy name when you see the word classify. So a polygon is classified by the number of sides that it has. And you learned these names a long time ago, so I'm going to go through them briefly right here, and that's the last time I'm going to talk about them. But you are responsible for having these memorized, or you got to know these, that the number of sides, if it has 3 sides, it's going to be called a triangle. If it has 4 sides, it's going to be a couple of things, and we'll talk about this when we get into the properties. It's going to be a rectangle or a square. Preferably, I can't say that word today, we want you to call it a rectangle, because a rectangle is a square. And we'll talk about that, like I said, in a few days. All right, number 5. If it has 5 sides, it's a pentagon. 6 sides, hexagon. 7 sides. Ladies and gentlemen, this is not a transformer. It is a polygon. It is called a heptagon, not a septagon. We're not talking about transformers. Heptagon. 8, octagon. 9 is nonagon. 10, decagon. 12 is dodecagon. You'll notice we skipped 11. So basically, when they're naming, where they're classifying polygons, they got a kind of a lazy at 11 and couldn't think of anything fancy. So 11 is just called an 11gon. So anytime you have a figure that has more than 12 sides, you're going to call it by the number of sides that. So this n represents the number of sides. We're going to say that this right now is an n-gon. So the term n-gon is where n stands for the number of sides, and this can also be used to name a polygon. So for example, a polygon with 14 sides is called a 14gon. And this goes for 11. Remember, 11 is just an 11gon. And however many sides you can have as many sides as you want. So if we had something that was 28 sides, it would be called a 28gon. So n stands for the number of sides that the polygon has. In an equilateral polygon, all the sides are congruent. In an equiangular polygon, all the angles in the interior are congruent. And now we kind of have a new word, and it is called regular. So a regular polygon is a convex polygon that is both equilateral and equiangular. So if we have a polygon that is both of these, we're going to say that it is a regular polygon. And also, so to be a regular polygon, you have to have 3 properties. Equiangular, has to be equilateral, and it also has to be convex to be considered regular. Now let's look at some examples. So we're going to tell whether the figure is a polygon and whether it is convex or concave. If you want to pause these and go through and try them yourself, you're more than welcome to, or we can just keep continuing and go right along. All right, in A, this guy here, you notice it has a line going through the interior, so this is going to be not a polygon. And that's basically because it's 2 figures made up of 1. That's why, because of the line on the interior, and I'm just going to say because it's 2 figures, not just 1 solid polygon. In B, let's see, everything is closed up. There are no curved edges, so yes, it's a polygon. All the vertices are pointing out, so this is going to be convex. C, that's a curved edge right there, so polygons cannot have curved edges, so this is no because of the curved edge. And D, let's see, yep, everything is straight, everything is closed, so yes, it is a polygon. Is it convex or concave? Well, you see we have these vertices pointing in here, so this is going to be concave. Next, let's classify. So remember, classify is we need the fancy name of the polygon by the number of sides. Tell whether the polygon is equilateral, equiangular, or regular, and explain. So let's see, in A, remember everything is marked there. So those tick marks mean all the sides are congruent. The arcs mean all the angles are congruent. So yes, this is regular because it's also convex. Classify, so let's count how many sides it has. 1, 2, 3, 4, 5, 6 sides. Hexagon. All right, in B, we see these two sides are congruent, but they're not the same length as these two. So right away, all 4 sides are not the same. And you can notice as well in the angles that these two are congruent, but these two are not congruent to them. So we don't have all angles and all sides. So it's not going to be regular. It's not going to be equilateral. It's not going to be equiangular. So it's basically none of those, but it is a polygon because it's a 4-sided figure. So basically we could say that this is a square, or more appropriately what this would be is actually a parallelogram. We kind of haven't talked about that yet. We're going to get there in a few days. So because, and it can't be regular or equilateral and equiangular because not all sides and angles are equal. All right, not all sides are congruent, not all the angles are congruent. All right, let's look at C, this cross. I see here all these little sides are congruent, so yes, it is going to be equilateral. Equiangular, well, it can't, I don't see it's equiangular because we have some angles here on the inside here. Okay. So it can't be equiangular, so therefore it cannot be regular. If we classified it by its number of sides, if we counted those, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 sides, so that is a dodecagon. And it's not regular because it's concave. So remember, a regular polygon has to be convex, equilateral, and equiangular. Okay, last one. Example 3. A table is shaped like a regular hexagon. So here is your responsibility for understanding what is all inside of that word. So remember, regular, again, means all the sides are the same. So as soon as you see that word regular, you're going to go ahead and mark your picture. And it also means that all the angles are the same. And at 6 sides, they already have a picture drawn for us. So the expressions shown represent side lengths of a hexagonal table. Find the length of the missing side. So here we are back to the same old kind of problem, is that you're still making an equation. So we have, here's an expression for one side and here's the expression for the other. Well, what do we know about the sides? We know the sides are equal. So we're going to set these expressions equal to each other. And solve. So see, we basically are still doing the same type of problems. It's just we kind of have new shapes and new words to go with. So again, we're going to read the question. It says to find the length of a side. It doesn't want x, so we've got to take that and plug it back in. So 4 times 2 minus 2, that is 8 minus 2, so the length of a side is 6 inches.